Thank you for inviting me to talk about visual analytics in time and space. My plan for today is I first would like to give a little bit of motivation why you should really think about visual analytics, why you should think about data user tasks. And I will also contextualize visual analytics. And my two main parts are two new research direction in visual analytics. One is guidance-enriched and the other one is knowledge-assisted visual analytics. And I will end up with some challenging opportunities, conclusions, and some hints, as you would expect, to talk about generative AI. Okay, let's start with my motivation. And I like to do some motivation and contextualize it in the sense in the medical field. I work a long time in the medical field, and I worked in the intensive care unit. And here you see the white people are the physicians, the orange people are the nurses, and here in between there are neonates, and the neonates have a lot of different monitors and connected with different devices. And the most important thing is that you have devices that are continuously assessed and you have devices which are discontinuously assessed. And this brings me to the point, which kind of information and which kind of, I always name it information, should be tackled. On the one side we have data, we have patient raw data, we have clinical guidelines. Clinical guidelines are textual contextualization, textual descriptions, how to heal a patient. On the other hand, we have different kind of resources. This is the one stream where we have the data. On the other side, we have different kind of users. For example, in the medical field, you have physicians, you have nurses, but you also have researchers in medical care. Then you have different kind of organizational issues, and the third part is that you have different kind of tasks what you want to do. You want to find patterns, you want to detect outliers, and then you have different kind of processes. This is particular when we design visual analytics approaches, then you mainly deal with data, user, and tasks. And to make our life a little bit more complicated, this is changing over time. If we have time, then our data, user, tasks are changing over time. Okay, now we have the different kind of components and we have the different kind of information. Let's look a little bit more closer which kind of data and information we usually have. We have usually time-oriented data, we have different kind of variables. We in the visual analytics community are not very clear if it's not very precise if it's parameters or variables. Let's use this interchangeable. We have continuous ones, we have discontinuous ones, we have time point-based elements, and then we have different kind of metadata, and we want to abstract horizontal, vertical or horizontal, taking one parameter into account or taking multiple parameter or variables into account. And what we also have in the medical field, we have the different kind of MRIs or CTs, but my research is not on image processing, computer vision, and I will not address to analyze this kind of images. Okay. Now you know which kind of data we have, which kind of user we have, and what we want to achieve. Let's think, why do we need now visualization? Why do we really need visualization? And in our visualization community, we have a nice example, which is called the ASCOMS quartet. And the ASCOMS quartet was designed from a statistical researcher who had the observation. If you look at simple statistical properties, the linear regression of these timelines are always the same. But if you look a little bit closer and look how they are really plotted, then you see there is a difference. This is quite nicely distributed. This linear regression would fit nicely. This is a little bit curved. It would fit somehow. Here you have an outlier. Therefore, the outlier checks that the linear regression is there. And here you have another outlier which also fine-tunes the linear regression that it's true. This is one good example which tells you if I just do simple statistical analysis, it will not help me because you need to look at the visualization on the other hand. And to motivate why you really need visualization, I have a very very intuitive and very small example. And for example, this is our data set, what we have. I ask you now, what do you see in this data set? Some kind of ideas. I mean, you're all dealing with data, sensor data, and so on. What do you see here? I help you. Because what we are doing in the visualization, we annotate raw data with metadata. I help you now. I tell you this is the numbering, 120, and this is the x coordinate, and this is the y coordinate. What? That's what I knew before. Okay, great. Now, please, what do you see here? I mean, this is our raw data. Annotate this with knowledge. Huh? Okay, this is exactly where the power of computers or analytical methods adds to the raw data. I can order it, because the colleague knows before that this is the numbering and this x is the y. I can help you. Here is the x and the y. I ordered it in a two-dimensional plane. Now what do you see here? Just think about your childhood. Main thing like numbers. Yeah? Yeah, I think I did it. I asked my students in this class, they don't do it anymore. Painting by numbers is the correct title. You are very close, you're very close. You're very close. It's an elephant in a palm tree. Huh? Very, very close, yeah? Very close, very close, very close. And this is exactly what we are doing on the visualization field. We're having our raw data, we annotate this as metadata, we use the power of the computer where it can add to, then we are doing this lining, and then the human checks the insights. Okay, now you're somehow convinced we need the visualization. We are back in the science again. Let's think about why do we need analytical methods. Why do we need analytical methods? Is because our data is so huge that we can't plot it on a usual display. If you just think about this screen resolution, which is approximately 8 million pixels, you need this kind of space. It's an old screen, but it doesn't make sense if it's an older or a newer one. The story is still the same. If you think about the yearly measurements, water level in Lower Austria, then you would need, it's more than 5 million, you would need this kind of space. If you go this idea further, then the number of cellular phones in Austria, 8 million, you would need this kind of space. And even if you think about transmitted emails every hour worldwide, you need 35 million. This means you need this big of screen, which makes quite clear that you can't use this kind of big of screen, and you need some kind of data reduction or analytical methods, or nowadays you would call them, we need some kind of machine learning AI to cluster the data or to project the data, whatever you want to say it. I just use the simple definition of analytical method, which can be simple statistics or machine learning or data mining. Now we have the component of visualization, and nowadays you have even more data. Now I try to motivate you why we need visualization, why we need analytical method, and why my last example is why does this analytical methods don't really work that out as we are expecting of. This is a simple example of the Hertzsprung-Russell diagram. The x-axis is the temperature of stars, and the y-axis is the magnitude, and this is the data set. And usually if a human would cluster this, they would cluster this in this region. If you use any algorithmic, any automatic analysis method, they are not really even good to cluster it correctly due to the noise and the different line of outliers. Therefore, we need our visualization, our analytical method, and the last component what we need is interaction. We are not producing beautiful pictures, we are supporting the process of knowledge gaining and the process of knowledge gaining to interactions. In the past you had these beautiful graphics, now you want to interact with the visualization according to the different users and tasks. And this brings me now to the definition of visual analytics. And visual analytics is the science of analytical reasoning facilitated by interactive visual interfaces. And the basic idea here is that you combine visualization and interactions with computer and mining and human perception and cognition. And it was grounding in the book from Tim Thomas and Kristen Cook, Illuminating the Path. And there was also a perspective from the European perspective, which was organized by Daniel Keim, about solving problems with visual analytics. Okay, this is just an example of our visualization approaches. I will select someone. Just to give you an idea, it's a process. We are not producing beautiful pictures. We are using visualization, analytical methods, and interactions to gaining knowledge. And we usually start with the data and have two different paths, using visualization to gain knowledge or using models to gain knowledge. And then we have the feedback loop. And this is not a one step, this is a process. And there are some critical elements which we need to tackle in this process. The one critical element is that we use visualization for model building, that we get some insights about the visualization. The other one is that we use the models for better visualizations. Then we need to have to fine-tune the parameters. We need to have different kind of interactions. And the last component is that we need to think about the quality of our data. And this is the basic visual analytics process model, what we are dealing with. Just to make clear, we have other nice different models. We have Van Wyck's models. I don't want to go in detail. I just wanted to give you a short story. This is not the only model what we have. There are a couple of other ones. But I will mainly focus on the Van Wyck model, what I will explain later on. And what we are doing is, this is a user-centered design. And what we are doing is, we are designing particular solutions for particular data, for particular users and particular tasks, which try to be expressive, effective, and appropriate. And to bridge the gap to what we are aiming for, we really want to illustrate the what, the why, and the how. The what is time and data, the why is the tasks, and the how are the visual representation and interactions. The third part, what I want to try to address is that we are dealing with mixed initiative processes. What does mixed initiative process mean? Mixed initiative process means is an approach where both the human and the user system can take the initiative and both contribute to the process. The basic idea is, it's an old concept from Eric Horvitz, who was a person dealing in AI and planning, and he tried to formulate this kind of interactions, particularly in the user, with user interfaces. And what is the main idea, in short? The main idea is, on the one hand, you have the user, on the other hand, you have the system, and what you're dealing is you try to use, the system usually presents some solution to the user, or the user conducts some exploration and decides something. And what we are aiming, what we are aiming for is where we try to combine the system and the user and really try to have the initiative from the system or from the user to solve some kind of stories. And the basic idea is that you deal with this blue box of mixed initiative, and that the both agents, how we call it, can collaborate with each other. Okay, I now wanted to give you some kind of introduction about what is visualization, why visualization is important. I try to give you an idea about mixed initiative and visual analytics. And in the second part, I will talk about guidance-enriched. What is guidance-enriched visualization? This is based on a project we did together with the University of Rostock, the Fraunhofer Institute, and the JKU, how it's called, the Johannes Kepler University of Linz. And the basic idea, in short, why we need guidance is, I told you about the different kind of visualization, the different kind of parameters, the different kind of analytical method. And usually the users are totally overwhelmed with the different choices. You have different kind of visualization, what you can achieve. You can have bar charts, or you can have pie charts. You have different kind of algorithms you can use, and you have different kind of parameters which needs to be fine-tuned for the algorithms, but you also have different kind of parameters to deal with the visualization. And usually the users can explore all the different, the whole design space, therefore you need some kind support the user in particular processes. And to contextualize in our community, we have 3 different terminologies. We have guidelines. Guidelines are applied in the developing phase of a visualization. We have the onboarding, which kind of helps the user to get familiar with the visualization and learn to interpret and use it. And in the middle, you have guidance. And guidance is to support the user while working with a visualization or a visual analytics approach. And this is what we are focused on. And what we did in this project, first of all, we defined what is guidance. In simple form, guidance is a computer system process. The very important thing is it's a process that aims to actively solve a knowledge gap encountered by users during an interactive visual analytics session. The basic, most important thing is that it's a process, that you have a knowledge gap, because you try to support the users to solve a problem, and that it's interactive. We base our approach on this mixed initiative approach, what I explained before. And what we did in this project, we tried to define the different aspects and try to contextualize what you need to, how to need to structure and contextualize it. And the first thing is, what is important is the knowledge gap. And in case of the knowledge gap, you can be familiar that you know the target, then what you want to achieve. For example, that you want to cluster something, or your target is unknown. For example, that you don't know which kind of algorithm you should use. The other thing is that you know the path, how do you achieve this process is known, and the other one is unknown. And on the other hand, you have the different domains. On the one side, you have, for example, data. If you think about this kind of networks, and you don't know where are interesting components in the data, you could take some visual cues like these arrows and illustrate the users to find, to explore this kind of path a little bit more in detail, or this path a little bit more in detail, to get some interesting data. The other thing is tasks. This is an example from Mark Streit about a biology exploration, where you have different kind of visualization, and then here you have different kind of paths, how you should analyze this. And one way of guidance could be that you try to help which kind of next step you should do and which kind of visualizations you should look at. And the other thing is that you could also need some guidance in case of applying which kind of visual analytics method. This is an example about segmentation of human motions, and there you have different kind of analysis, and the system could support you using this kind of heat map to do so. This aspect, the first aspect was to capture the knowledge gap. The second aspect, what you want to select to specify guidance, is the different kind of input, the data, the domain knowledge, the images, the user knowledge, and kind of history of interactions. And the other one is the output, that you give an answer or you give a means. And to give an answer is that you give some kind of hints how to solve the knowledge gap. For example, we define this as a function of the knowledge gap we have discovered to taking which kind of input data to find the answer. It's kind of interactive process. I know that I didn't have explained you how to detect the knowledge gap yet. This is a tricky thing, but this is the basic assumption, is that the user have a knowledge gap and you try to find to solve it. This is the answer, and the means is, for example, if you have this kind of clustering algorithm and you give some kind of highlight, this kind of parameters would be good to explore in more detail to come up with a better cluster algorithms. Or if you have here parallel coordinates, there you have the coordinates are different kind of variables or parameters, and the lines are different kind of distribution of one data set, and you can give the hint, this would be a good stuff where you can explore a little bit more. Or the other example, what we had before, about the network, that you check out this kind of data in more detail. And this brings us up with the whole aspects. On the one, the data gap, the input and output. And the last one, what I didn't explain, is the guidance degree. And we distinguish between 3 different guidance degrees. One is orienting, one is directing, one is describing. And what does this mean? Oriented is the lowest guidance what you have. The basic idea is that you have to detect a knowledge gap, and you just want to give the user a kind of hint what he or she should do next. In this example from Mark Streit, we had here a list of different tasks, and you just tell the user, this is the different tasks. I would recommend you to perform this kind of task, giving a hint. The second one is directing, and directing is more the second level of guidance. And the basic idea is you have to detect the knowledge gap, you know what the user wants to give, and you want to give particular alternatives what the user should do next. For example, in this case, you have different kind of visualization, different kind of data, and you don't know which kind of visualizations you'd use, and you would recommend this different kind of visualizations. And the last one is prescribing. And prescribing is a very strict degree of guidance where you really predefine the different steps what you should do next. For example, in this example, that you should really explore this, then that, and then this, that. And what we did, we used one of our famous visualization models. This is the one model from Jaak van Wyk, where you have a component about the visual analytics and a component of the user. And the different boxes are containers or artifacts, and the different circles are functions. And the basic idea is, as we had before, you start with the data, you have some visualization, you produce some images, then there comes the user side, where the user perceives the different images, gains some knowledge, put it back, and explore the data even more through a specification. The specification describes which kind of visualization, which kind of interaction, and which kind of parameter setting, and which kind of algorithm should be used. And what we did is we enhanced Jaak van Wyk's model with the guidance approach, which come up with the different kind of components what we had here. And then you come up here that you have prescribing, orienting, and directing. This is just you don't have to explain this in detail. I just want to illustrate. We did our homework. Yeah? We tried to put it in a very easy thing. But I would like to illustrate it, and oriented is where can I go, directing is where should I go, and describing is take me there. I would like to illustrate you with a short example how you could solve, how guidance-enriched visualization works. And this was a work what we did together with Davide Ceneda and Christian Tominski from the University of Rostock. And the problem is guided visual analytics for cyclical patterns in time series. And the problem is you have a time series and you want to detect cycles or patterns, and you don't know which kind of cycles and patterns is the correct one. And our solution with guidance is that we try to support with some statistical methods to help the users to find the correct cycle. Let's do this in an example. We had the knowledge gap. The knowledge gap was the target is unknown because we don't know the parameter of the cycle length. And the data is to find the cycles. The second step is the input is the data itself. And the algorithms, we use 2 different algorithms. It doesn't matter what the algorithms do now at the current to understand guidance. I just want to say we use 2 different statistical algorithms, Fourier transformation and the other one. And the output was somehow to indicate what are possible parameter setting And since we are dealing with cycles, we try to decide about this spiral representation, and we try to decide about a different kind of sliders to help the users to find the correct cycle. And from the degree we used oriented. How does this look like? We designed a slider, which a normal slider just helps you. Here you find the usual size of the cycles, and we enhanced the slider with guidance. And the enhancing of guidance is that we introduce this algorithm, and then the algorithm shows you with these peaks, this could be an interesting length or segment of the cycle. And because this was hard to see, you could zoom in details on demand. And how does this look like? You can move the slider. You see here the different kind of elements. And here you see a glow, and the glow illustrates you are close to this example, close to the correct sliders, to the correct size of the cycles or not. And this somehow helps you to, illustrate this. In an example, this is the time series. Here you have the slider, and the person could search around to find the appropriate one. This was the first example to illustrate you how to use this kind of slider. The second example, what I would like to give you, is an example which is dealing with pictures, but I don't interpret the pictures. It's about, I come to this. It is a collaboration between our computer vision people and some companies who try to find picture. If you build a building, you need to explore if there was some. I go to this. If you want to build a building nowadays, you have to find out if there were some bombs and were not detected and were not exploded, and you need to find some safe way that there is allowed to do the bombing. And the basic idea here is from the process, you have we collaborate with the Luftbilddatenbank. The Luftbilddatenbank do these selections, and they have a database with different kind of images, these aerial images. And the basic problem is they have a lot, but it's very expensive. But they need to find the correct ones to detect if there were unexploded bomb from the First or Second World War. Then you do this filtering, and then you do the image selection, and then you do the georeferencing, and then the image analysis. And our part was that we tried to find a good way to select appropriate images from the database according to particular characteristics. And what we did is we built a user interface which was encoded for particular time aspects. Here there is the time aspect, and here there are the different kind of flights. I forgot to say, these airplanes flew over the area, and they had two cameras, and sometimes both cameras were working, sometimes not both cameras were working, and there is also stored a lot of metadata about this kind of images. And on the one hand, you have here the time axis. Here you have the different flights, according the images. This is the circles. The size of the circles measure how big the circle is, how important is this kind of image according to the metadata. If they are connected like this, then they are in a series. Then there is a flight with the different images. And then there is the attacks where they see something, and then you could select it. And this was combined with a real image. And then you could see this was the the green one is that the user selected, and you can select from the time and see the different images. And then you see them in context of a current visualization. This is the case in Vienna. And you could, our approach tries to guide the domain expert which kind of images should be selected. And this is a more complicated interface where you had also the guidance included. Green is when the user selected, orange is the prescribing, which one our algorithm would detect, and the blue one is orientation, and this could help the people to select. Just to contextualize, this term of guidance is sometimes used differently. For example, some people, like the people from the ETH Zurich, call it co-adaptive guidance, which means they have a similar concept where you have the user and the system, and you have different kind of tasks about the user. The user can learn and the user can teach, or the system can learn and the system can teach. And the people here, we call it guidance-enriched, and they call it co-adaptive, because the basic idea is that you have different kind of paths how you do the co-adaption. Just to contextualize, these are different kind of terms. This brings me now to my third part. I try to illustrate you why guidance is needed, and guidance helps you with this different kind of components and aspects in the visualization. And the second part I would like to address is how we can do knowledge assistant visualization, and what does this knowledge assistant means, and where does this knowledge assistant come from, and how we can incorporate it in our visual analytics solution. Okay, knowledge assistant visualization. Again, simple motivation. We have our system, we have our user, and we have a lot of different knowledge. Part is externalized in the machine, but other parts is tacit knowledge, which is only in the head of the users. And in our community, we distinguish between explicit knowledge, tacit knowledge, operational knowledge, and domain knowledge. And explicit knowledge that can be processed by the computer and transmitted electronically to store in a database. Tacit knowledge is only in the head of the person. And operational knowledge is the basic idea to explain you how to interact with the system, and domain knowledge is really knowledge about the application domain, how to tackle this. And in my example from the beginning, I had this guideline-based care, what I was mentioning, and you had the different visualization and different kind of interactions, but you could also have the computer interpretable version of the textual guidelines in a database. This is the basic idea, is that the guidelines which are written, the guidelines were how to heal a patient, and the guidelines could be formalized in some planning language or some kind of computer interpretable way, and you could use this knowledge for the different visualization. And but you also have some kind of automatic and analyzing techniques like compliance analysis, temporal mediator, or you could add this even more. And the input is the electronic health record. This is the basic idea, how this knowledge comes from in the medical field. What we did is, I already introduced you about Van Wyck's model, and showed you how Van Wyck's model was enriched for guidance. Our famous Jaak van Wyck. Eindhoven University, TU Eindhoven. And what we did is the same with machine. First it called was visual analytics, and here's the human. And what we did here is we enhanced it with the component of tacit knowledge. The tacit knowledge is on the perception element. We enhanced it that the tacit knowledge can be explicit, represented in the database. We enhanced. Before we had only the specification. The specification helps you to find which kind of visualization and algorithms could be used. And the analysis gives you more hints which kind of analysis you could do, for example, clustering or other things. And then the externalization of this different kind of knowledge to perform the exploration. The reason why we always use the Van Wyck model and not the other models is Van Wyck models is an old model, it's from 2006, But it's very clear with these components of users or visual analytics, or he called it visualization, and the human. And it's very clear with the different components what are the containers and what are the functions, and you could nicely enrich it. Just to illustrate you the analysis component, you could use here some mining techniques or simulation or even guidance, or we also try to enhance these concepts for process mining. Process mining is consists of discovery of processes, compliance, and process extensions, and we try to make some experiments how to do it. But just to give you an illustration about this, I would like to go into examples again from the medical field. And the first example is the Care Cruiser, which was a work by Teresa Gschwandner, where we try to do an interactive exploration of the effects of treatment actions on patient conditions. And the basic idea of this is you have the user, are medical experts or physicians, somebody who is doing observing the physicians on a daily basis. The data is patient data and treatment, and the data is multivariate and abstract, and from the time dimension is linear and instances. And what I already phrased, you want to explore the effects of the different clinical actions according to the reaction of the patient. And we had such a multiple coordinated view interface, where on this side you see the a visualization, a flowchart visualization of the therapeutic actions. Here you see an overview about this, a tree-like overview about the visualization of the clinical actions. This is the root, and if there are these diamonds, this is different kind of actions. And then you go in this detail and see what you should do in detail. This is the visualization of the knowledge of the clinical guidelines, which are represented in a clinical and a computer interpretable representation, extension of a planning language, what I don't explain in detail. And here you have two time series. One, it's again artificial ventilation of newborn insides. Here's the other one. Here you have the range, the normal range, what the patient should be in as fast as possible. And here you have the therapeutic actions. And here you select the therapeutic actions, and you see this in detail. And then this is the decomposing of the different therapeutic actions. And what you can do, you can align them to see how the patient is treating. You have different kind of functions, how severe the patient is deviated. I just want to go to the slope. And then I will give you an example how this works. Sorry. And the basic idea how this works is that you select some actions here, then you see the parameters. You're interested in the action, how the actions are affect the healing of the patient. Then you can align them according to particular actions. Then you can zoom in as usual to interact with them. And you are interested in the slope, and the slope specifies in a function how fast is a prediction how the patient will heal, and you're only interested in this upper case, and then you have a lens where I can explore around and see how this affects. And then you can nicely see that this is an action. There is the patient is, there is the patient very stable. Here is the patient very stable. Here it's a little bit oscillation, and this is also very stable. But it's a nice idea to see how you can. The basic idea is that you use this kind of knowledge of the clinical guideline to structure, to compose the different visualization, and you know the knowledge about how to heal a patient with structured in the knowledge in a clinical guideline to use this kind of, to predict the different kind of effects. My second example is GNEUS. It's a knowledge assistant approach, which was done with the University of Pavia and the colleagues of Israel. And the basic idea here is, again, you have the same user, you have the same data, but you want to detect patient patterns. And here the most important thing is you're dealing with patient cohorts. At the previous example, I had only one patient with different parameters, and now I'm dealing with the patient cohorts. And this is the kind of visualization we used. The first one is, again, we had these guidelines represented here. The overview is on the upper part, and here's the lower part. Here you have to see the different guidelines. Then you can see a temporal abstraction of the guidelines. This means one line here is a patient, and you use kind of abstraction if the patient is normal or abnormal. This means if it's red, it's high, and it's blue, it's normal. And you see here an overview about the different kind of patients. Here you see the view of a stream box plot. The basic idea is you take particular elements, time windows, and you calculate box plots according to this time window. And the last one here down is the treatment of the patient. Again, we had these actions, and the hull specifies you, according to this patient cohort, which kind of actions could take place. And the color coding are the different kind of actions, and the size and the different coloring specifies how a patient, if a patient was treated according to these actions. And if there is a white space, this means there would have been patient who would be eligible to get treated this way, but they were not treated. And then you could use kind of interaction navigation, and you could use some kind of magic lens, because this, I told you, this is just a timeline. And if you want to see, this is, you don't see the distribution nicely, and you could use such a magic lens to see the distribution of the particular time regions. And the last nice feature is that you have a kind of focus and context technique. And the basic idea of focus and context is we are dealing with patient cohorts, and you would like to look at a patient in more detail, but also see how the other patients are treated. And this means this patient you would see in focus, and then you see here how the other patient is treated. And the same you see here in the stream box plot. The orange is the patient selected, and then you see how the distribution is on the other, and also which kind of actions you can take. Okay, from the timing. I would give one more example about knowledge assistant before I go to my conclusion. And then now I have a totally different domain. I had a lot of medicine, but I have a totally different domain. And what I also very interesting is to understand art history and understand how the different kind of movements, events change over time and space. And there we had a PEAK project. PEAK is a particular program at the FWF, and it was called Interactive Music Mapping of Vienna, exploring a city from 1945 up to the present. And the basic idea was that we were working together with art historian, and they wanted to explore how the city of Vienna changed according to particular events which took place there and which kind of impact they had. And one subcomponent was that they wanted to know how the different artists changed, how they were honored during their life period. I already explained this, and the basic idea was user are people from the humanities and art history. The data is event-based data, network, because you want to know the connections. You have multivariate, You have multivariate data, linear, and you have space. And we applied one well-accepted task taxonomy from our community is from Bremer-Munzner that you want to present, compare, and explore. And the basic idea, this is we had different kind of scenario, and one scenario was the scenario of Musikstadt Wien Reloaded, where you had here the Vienna, and you have different festivals, and then you have different artists who are taking place, and we wanted to explore what was the influence of the different artists which were exiled and when they were honored. And we used a kind of interesting visualization, which is called circular prototype, where we had the time, then we have the period of birth and death, the lifespan, and then there was the exile period, and then other events. And we used a circular layout that here you have the different artists and how they are ordered, and they can be also ordered according to different other elements. You could use this visualization also to apply it for locations, and this was the prototype what we had, and this was the prototype how you could interact with it. For example, you could select here, you can order it according to death, when it was honored, and then they changed. This means one of these lines is one artist. These were the different roles. It was a composer, a conductor, or a musician. And you could order it according to the different kind of elements. And what was quite nice, what we discovered is, these are 4 different scenarios. This is the first scenario that you ordered it according to the birth. This is the birth, and you see a nice time. This is according to the death, and this is ordered according to the honored period of the persons. And there you could, and the basic idea is that you could really explore what's going on and what's in the data. This is just the scenario what we had. Okay, let's bring me to the conclusion and what you can learn about it, or what I try to convince you with a couple of examples. And before I go really to the conclusion, but Christian, I'm nearly finished. Don't worry. I'm still a little bit of time. I didn't say anything about large language model, generative AI, or visualization. And I think nowadays everybody is talking about this stuff. I had to address it. And we do a lot of, our community is doing a lot of studies how we can use it and where is a good way to apply it. And for example, it's a good way. This is a survey what Enrico Bettini did recently. Very good, it works if you use prompt engineering to get some kind of visualization. Very simple prompt, very simple. It uses perfectly nice for this image synthesizes for visualization. For example, here you have a tree map, and you want to visualize them more engaging, and you visualize this like a tree, or here you have a scatter plot, and try to engage it with different kind of fruits to help the people to see more insights. There it works really nice. This is large language models can do. The other cases what we need in the visualization community, for example, you have some visualizations and you want to get, and usually the people need to really to read the visualization to understand what's going on, and you want to get some narratives to help people who are not expert in the visualization to explain this, having some narrative sequences. This is very limited because currently all the generative AIs are not really explaining this perfectly. But I have also to say, this is a study which was done a couple of weeks ago. Everything is developing so fast, I can't tell you this is the truth nowadays, because this is changing. And what is really bad, if you just give a specification, and ask the generative AI, a large language model, they were testing it with different ones, produce me a beautiful visualization and do me something like this. It's really horrible, it doesn't work. Again, a survey was just recently done. Therefore, our community really likes to explore large language models and how to deal with it. But we really need to take this carefully. Okay, this is my excursus to large language model and generative AI, because I think I have to address it. In giving a talk without addressing it is not good. Okay, my challenging and opportunities, what I wanted to finalize it, I try to motivate you that visual analytics is a good solution where we try to combine visual and interactive techniques with computer and mining and enhance this with perception and cognition, and it's enriched. It's an somehow an interdisciplinary approach, and I try to motivate you that we need good concepts, conceptual models, and what I presented you is the knowledge assisted. This was from Federico, and the guidance-enriched. This was from Davide Tinada, which is one approach how we use a well-established model for visual analytics to enhance it with this kind of components. And it also bridged to my initial example where I had this elephant and palm tree. Yeah? If we really are able to use this kind of domain knowledge and are able to use this in a formalized way, that it can also be used by the visualization as well as on the analytical method, then it will gain some insights. The other aspects I try to motivate that we don't using generic visualization. We are using visualization or visual analytics approach for particular data, user, and tasks. I try to motivate with Tamara Munzner with why, what, and how this can be done. And I have some aspects which I didn't address, but I didn't have time. But I think you have to consider it. One, you have to consider if you do visualization or any kind of visual analytics approach, or also some machine learning, you have to be aware about the data quality. And usually the data quality is really a big issue. If you do some transformation, you also need to trace the data provenance, how you did it, to interpret, to contextualize what you did with the data before you do something. We have a lot of uncertainty. I talked about uncertainty. I didn't talk about uncertainty at all, but we have uncertainty. We have value uncertainty, we have temporal uncertainty, we have spatial uncertainty, which we need to take into account. And we really need to have a better interactions, better science of interaction. The other thing is evaluation. I didn't talk a lot about evaluation, but we in our community have a lot of different techniques to evaluate. We have qualitative, we have quantitative, we have heuristic and multi-step, and currently we are really much in the field of using some heuristical approach to assess the quality of our stuff. I skipped this. The other thing is what I didn't address, but we need to address is explainability. We tried really to see what we've done. We can call it trustworthiness, explainability, faithfulness, everything like this. And this really needs to be tackled even more. And I try to give you some kind of application domains what I'm interested in. Okay, I thought this is very important. I showed you the different elements. I didn't mention this, but visual analytics is detect the expected and undiscover the unexpected. We have a mixed initiative approach. The why is structured, what is structured according to diamond data, why, the task, and the user. Some self-advertising. We wrote a book about time-oriented data. It's second edition. It's even more content on space. I did this already. I have to thank my team and all the other people, all the funding agency, and thank you.